Okay, guys, so let's start. So good afternoon, everybody. So last time I started chapter 2. I told you in chapter 2, I'm going to teach assembly language. So, and then I told you any assembly program should have two things. One thing we call it directives, okay? The other one, the other part in your program should have commands and instructions, okay? I told you the directives, they are instructions to the to the assembler, not to the microprocessor. So they don't have machine code. They are not going to be converted to machine code. They are not going to be executed by the microcontroller. You are just telling the assembler, please, my assembler, store this data in this place, or I wanna do something just to the assembler. Okay, uh, so but the command is these commands should have a machine code. They should be run by the microprocessor. Okay, I finished last time directives, and today I'm gonna start commands and instructions. Okay, just make just a very quick refreshment or very quick review. I told you directive like org, as I said, your program should have two orgs at least, one for data, one for code. Okay. One more thing, yeah, we use directive like dc.b, and these directive are used to define variables. I said we have two types of variables. We have byte variables and word variables. Also, they can be initialized and uninitialized. Also, they can be variable or arrays. So I explained how can you do that this way. I explained also how they are stored in memory, because in any programming language, even in C or Java, whatever, once you define a variable, okay, this variable should be assigned to a physical location in the memory, physical location, so that every time you write to the variable, you actually write to the physical location. Every time you want to read the variable, you actually read the physical location. Here, because this is assembly, because we are very close to the hardware, it's easy to see the physical location. Maybe in C, all this, it was hidden, right? It was not easy to know where is your variable exactly in memory, right? Anyway, I made something, explain this one very clear. I told you the coming Friday you are gonna have a quiz. This quiz, I'm gonna give you something like this, okay, and then I'm gonna ask you to draw this one. I just want to make sure you understand what I explained here. You understand once you define variables, once you define arrays this way, how they are stored in memory. Okay. So anyway,
You said this was on Friday or on Thursday?
I'm sorry, Thursday. I'm so sorry,
Oh, it's
because
okay.
because I always, my lab is always on Friday. That's why only in this semester they make it Thursday. So I'm sorry. Yeah, thanks for notifying me. Yeah. So I mean in the lab on Thursday. Okay. So anyway, so I explained all of that last time. Now I want to start commands. Okay. So these commands, as I said, guys, these are an instruction to the microcontroller. Okay, and this will be converted to machine language. They will be converted to machine code. Okay, as I explained before. So even any command should actually tell two things, right? Number one, the command has to tell what operation you want to do. You want to do addition, multiplication, shift, rotate, whatever. Okay, so for sure the command has to tell me what operation. Is that enough? No, it's not enough. You have to tell me also where is the data, because if you want to do addition, this addition needs data, right? So I for example, I need to get two numbers. I have to add these two numbers together, and I have to store the result somewhere, right? So you have to tell me. That's what we call operands. So here in the operands, you have also to tell me where are the source and destination of the data. Okay, where I have to get the number to do this operation, and where I have to store the result. Okay, so before I teach instructions, in this part, or maybe in the whole lecture, in today's lecture, I'm gonna focus on operands. How can we represent operands in the commands? Okay, how can we write them? And also, what are the different operands we have? Okay, so operands can be a register, right? Make sure, for sure, right? So you want to add one register to another register, the content of a register, okay? So your operand can be a register, it can be memory location, the content of a memory location, or it can be immediate value. Immediate value here means it's a constant value, okay? I'm going to give you more details for sure. But these are the three types of operand we have, okay? Registers and memory location can be source, also can be destination, okay? For sure, I can do addition and store the result in a register. That's why it can be a destination. Also, I can do addition and store the result in a memory location. That's okay, right? But it's a constant value. It's not a location, so I cannot store. So it cannot be destination, but it can be a source of the data, okay? So, any questions so far? I'm going to give you more details. Any questions? Okay, let me give you some examples first. For example, guys, I want to do something like that. I want to add register A plus immediate value or constant 20, and then I want to store the result in register A. So this is the source. These are the source. I have two sources of information for data. This is the operation, is addition. I'm gonna get one number from register A, as you see here, guys. So here, this is the source of your data. Here, this is a constant value 20. So I'm gonna get 20, number 20. Also, I'm gonna add the content of register A, and then the destination will go to A. Is that okay? So where are the operands here? I have two operands here. One is register, the other one immediate constant value. Let's see another example. Here, we have here two operands. Both of them are registers. Okay, as you see here, guys. I want to add register A plus register the content of register B, and I want to store the result in register A. Okay. Let's just give me 1 second. Okay, now it's okay. Sorry, it was frozen. Okay, let's have more example, guys. As I told you, also operands can be memory location, something like that. For example, I want to add a constant value, or we call it immediate value 20, to the content of a memory location number, address number 1000, the content of this location, and then I'm going to store the result in A, something like that. So I'm going to get 20, for example, and then I'm going to get the content of this location. I'm going to add them together and store the result in A. Another example, I can add here immediate value 20 plus a content of a register, and then I'm going to store the result in the memory location number 1000, whatever there. Okay. I'm not sure. It's not. Let me take next. Okay. Okay, guys. Any question? Okay. So let's agree now. Let's agree. Any instruction needs operand. This is number one. Okay. Number two, operands can be one of three things. They can be constant or immediate value, register, or memory location. Now, what I'm going to teach now, before I teach any instruction, you should understand, okay, how can we represent these operands? So if you mean it's a memory location, what is the format? How can you write it? If you mean this is a register, or if you mean if it is immediate value. So let's start first with immediate value, okay? So if you mean this is immediate value, that's very easy. You have to put here hashtag before the number. Very easy, right? So in any instruction, if you mean this is immediate value, just put hashtag before the number as shown here. Is that okay? In other words, every time you see hashtag here, don't think about it. This is just immediate value. It's not a memory location. It's not a register. Just immediate value. Very easy, right? So here, just to explain, I'm going to use one instruction. For sure, I'm going to teach all instruction later. But for now, I'm gonna give you very little information about this instruction. We have an instruction called load instruction. This instruction should copy immediate value or the content in a memory location to register to one of the register. For example, if you look at this one, guys, load register A. So this one is gonna copy number 20, put it in register A. So what this instruction is gonna do, actually, A should equal 20, because in assembly, unlike most of the high level programming language, we don't have equal. Instead of equal, it has to be instruction like this one. It has to be done on the hardware. Is that okay, guys? So we don't have equal in assembly. Instead of equal, we have to use instruction like this one. Is that okay? So once you see something like that, that means we're gonna copy register A. We're gonna copy this operand here, which can be immediate value or memory location. As I said here, I'm gonna copy it in register A. So here in this case, this is number 20, okay? But also, you can, like as we did before, any numbers here, you can represent them in any system. So here, because I don't put here any prefix here, so this number is decimal. So register A should have number 20 decimal. Is that okay? However, if you want to put the number in hexadecimal, that's okay. All what you have to do, just put the dollar sign here. So what this instruction, this another instruction, load B, register B with and because of this hashtag, so this is not a memory location. Don't think about it. Hashtag means constant value. So here I'm gonna put number 20 hexadecimal in register B. Is that okay, guys? So for all the instruction I'm gonna teach in this chapter, every time you mean or you wanna write immediate value, just put hashtag. Very easy, right? So also you can use any system. So you can put percent if you want, or hexadecimal or decimal as here. Okay. Any questions? Okay. Again, what I'm doing right now, guys, I want to explain. Now we have 3 types of operands, right? As I said, register, immediate value, memory location. I'm explaining if you want to use any one of them, how can you write them in assembly, okay? For any instruction, okay? But let me still, I have a problem here. I don't know. Okay. So, okay, I think I explained this one before. We agreed every time I put like a square bracket this way, I mean the content of the memory location that has the address 1000. Okay, so here so every time you see something like that, that means it's for sure. This is not an instruction. This is just for us when every time I write a command. But this is just for us. Okay, so it's not an instruction. So this means the content here. Okay. Okay. One more thing here, guys. I here another instruction, load X, load register X with this number. Is that okay? So here, after you execute this instruction, this number which is a word is going to be stored in register X. Is that okay? Another important thing you should learn, very, very, very important thing. Okay, listen to me. Some instructions are actually are gonna work on bytes. Some instructions work on words. Okay, so how can I know if this instruction is for byte or for words? How can we know? Okay, simple, very simple. You can know from the instruction itself. So every time I teach one instruction, guys, I'm gonna tell you this instruction for words, it's gonna work on a word. But every time if it's an instruction is for words, I'm gonna tell you this is for words. Okay, so very simple. Load A, okay, this one is gonna work for words. It's gonna copy a word. But this one here, load X, okay, so this one is gonna be stored in X, which I'm sorry, A for byte, okay, because A is a byte. X for word, right? So this one I'm gonna store here. Here number 20 is gonna be stored in a byte. So A byte, so I'm gonna store 20 in a byte. But here number 20 is gonna be stored in a word, right? So it's gonna be stored in a word. Same thing, you can put percent here. You can put something like percent and put the number in binary. It's okay. Okay. I want to leave this one for later. So now, so the second part now I want to explain, guys. Now, if your operands are register, how can you represent them or how can you write them in instructions? Okay, so here if they are register, we actually just use the name of the register. So you can use A, B, X, and so on. Here I give you one example. In this example, we have an instruction called transfer. So TFR. So this one actually, this instruction is gonna this instruction can copy a register to another register. Okay. So here actually you have to write here TFR, and then you have to write here the source register, and you have to put here the destination register. And all what this instruction is doing, this instruction should copy this register to this register. Okay. So here it has to be a register. Here it has to be a register. Is that okay? So how, if I wanna write a register, how I represent the registers? Very easy. All what you have to do, just put the name of the registers. Okay. I give you some example here. If I say transfer A comma B, what this instruction is gonna do? This instruction is gonna copy register A to B, right? So that means B equal to A. Always, don't be confused. Always the source. Here we write the source first, and then we write the destination next. Okay. Maybe in other assembly language they do the opposite, but here for our assembly language we write the source first and then the destination next for all instructions. Okay. So another example here, I can say transfer. Okay. Transfer again means copy. You copy. So here copy X to Y. What this one is gonna do? Y should equal to X. Is that okay, guys? So very easy. If your operands are registers, just use the name of the register A, B, X, Y, and so on. Very easy, right? Any questions? Okay, guys. Okay. So now I wanna move to the third case, which is maybe it's gonna take some time because we have different ways for operand. If your operand is a memory location, we have different ways. Okay. But quickly before I go here, let me summarize what I said. We have your operands can be immediate value, and in this case you have to put hashtag. Okay, very easy. So you have to put hashtag, and then you can represent the number in any number system, but you have to put the correct prefix or the proper prefix, as I said before, percent, dollar sign, and so on. This is number one. Number two, if your operands are registers, you can just use the name of the registers. Okay. Number three, if your operands are memory location, now we have different cases I'm going to explain right now. So let's start. So here, if your operands are memory locations, okay, so it can be direct or extended mode. We call it direct or extended mode, or it can be indexed. Indexed here means pointer. You are using a pointer. Okay. So let's start. I'm going to give you, this is like summary, but I'm going to give you the details. Okay. So here, in case of direct or extended mode, if you want your operand, if it is a memory location, just to put the address there. That's it. So for example, if you see number 20 this way, okay, that means it's a memory location, and this is the address. So when I say load register A20 this way, what it means? It means I'm gonna copy a byte. From the memory location number 20. So this is address and this is memory, right? And then I'm gonna copy it in register A. Is that clear? Okay. Remember, there is no hashtag here. If you put hashtag, it's completely different story. If you put hashtag, so it's not a memory anymore. It's number 20, constant value. Okay. Okay. That's what we call direct or extended mode. For pointer, we have different cases. I'm gonna go through them. So one case. So here, I think you know what pointer means from C language, right? So, but I'm gonna make very quick revision. Pointer means you are using one of the register to store the address of the location you want to read or write from memory. Keep in mind, everything here is memory, right? Here, the address is here, 20. However, in all these cases, because they are indexed, because you are using a pointer, the address should be stored in register, right? So your address has to be in a register. So here we have 3 cases. One case you can put constant, comma, and then you put X or Y. So every time you see something like that, a number, 0, 1, 2, whatever, comma, X. If you see something like that, this is one operand, only one operand. It's not 2, it's only one operand. And this means a memory location, okay? Which memory location, as I'm gonna give you details later, it is actually the content of register X plus 0, give you the address, okay? So X here like a pointer. So here, this is a memory location, this operand for a memory location, and the address of this memory location is X plus 1 or X plus 2 or X plus 0. There is another way. You can put register A, B, or D this way, and then you can put one X or Y, one of them. So it can be something like that. A comma X, it can be A comma Y, it can be B comma X, D comma Y, and so on. Every time you see something like that, very easy. This is memory. And okay, and this is using indexed, okay? So where is the address? Because if it is a memory, I have to get the address in order to read from this address or write to this address. I need the address. So in this case, the address is actually the content of X plus the content of A, the content, and so on. For sure, just to give me more time, I'm going to explain why we have different, how can we use something like that, or this one, and so on. I'm gonna give you more details, but for now, let me finish the big picture. So for now, I just want to show you the big picture, and then I'm gonna go for the details. Okay. The third one we have here, we call it auto increment or auto decrement. Okay. So this one, as I'm gonna, so it looks like something like that. You have a number here, comma X, number comma Y. So it's like this one. Yes, it is like this one, number comma X. However, the difference between this one and this one, you have here plus or minus before or after X. So this one is exactly like this one. That's true. But the difference you can see here, guys, plus before or after. That's why it's called increment or decrement. Okay. So I'm gonna give you details, but for now, yes, this one is exactly like this one, but this one, because of this plus, is gonna do one more operation. So this one actually is gonna also increment X. This one doesn't increment X. Okay. Anyway, so let me tell you the summary and now go to the details. Don't worry if you didn't understand anything. I'm gonna go for the details. I just wanna show you the big picture. So the big picture is, if your operand is memory, we have four formats, as you see here. The first format, just a number without hashtag, and this is the address, right? This number one. Number two, if use indexed or pointer, okay, and usually, by the way, usually we use a pointer in case of if you want to read arrays, okay? So usually this part is used for arrays, as I'm gonna explain later. This number two, if you see something like that, number comma X, number comma Y, X or Y for sure, so this is a memory, right? Or if you see something like that, A comma X, B comma Y, and so on, so this is also memory, right? Or if you see something like that, it is memory. So for memory, we have four formats, as you see here. Now let's go to the details. This is just a big picture, okay? Okay, let's start with the first one. As I said, guys, look here. When I say direct or extended, it's called direct or extended mode, the first one here, okay? So here I can say load register A with 20. Very easy, guys. This is when you see something, sorry, with 10. When you see something like that, guys, so this is a memory location. So, and because this instruction should copy a byte, because this instruction is for bytes, okay? So what's gonna happen here, we're gonna copy a byte from memory location number 10 and put it in register A. So what this instruction is gonna do, as you see here, I'm gonna go to location number 10. I'm gonna read a byte. I'm gonna copy a byte from there, put it in register A. Okay. For sure, if you put hashtag, now it's completely different story. With hashtag, this is not a memory location. This is number 10, right? So you have to understand the difference between these two. Very important, right? So here in this case, what this instruction is going to do, register A should equal number 10. Okay, let's have another example. If I say something like that, oh yeah. So here, I wanna tell you we have another instruction. We call it store. Okay. For now, don't worry. I'm not teaching instructions yet. Okay, I'm teaching how can you represent operands. That's what I'm teaching. Okay, but for now, in order to teach this, I need two instructions I'm going to use here. One is called load. I told you load means you want to copy immediate value or register. You want to copy it to a register, immediate value or memory location to register. Okay, store should copy a register to memory location, the opposite. Okay, so store should copy a register to a memory location, or memory location should equal register. Let's see this example. I'm going to say store A in memory location 2000, right? Look here, guys, because once you see something like that, like this one, this is a memory location, right? Once you see something like it, this is a constant value. That's what I'm teaching, right? So here what I'm saying, now you store or you copy the content of register A, which is a byte, you store it in memory location 2000. So after you execute this instruction, the content of register A has to be stored in the location 2000. Any question, guys? Okay. Hello, should I continue? Are you okay? Okay, let's yeah, great.
We're good.
Okay, good, guys. So maybe I have more examples here. Okay, so let's see. When I say load accumulator A 1000, what it means when you see something like that? It means I want to copy a byte from memory, okay, which location in memory 1000, and put it in register A. So A should have a byte that's stored in location 1000. Is that okay? Now, if I say load accumulator A hashtag 1000, is that, can I do something like that? No, this is a wrong instruction. This one is okay. This one is not okay, right? Why? Because this is a memory location. I'm gonna copy a byte from there, put it in A. But this one here, I wanna put 1000, which is a word. I wanna put it in A. Can I put 1000 in A? For sure, no, because this is a word and this is a byte. So this instruction false. Okay. Let's see something else, guys. Here, when I say load register D 1000, yeah, that's correct, right? Because this is a word and this is a word. So I'm going to store 1000 in register D. So after you execute this instruction, register D, which is a word, should store 1000, which is a word. Okay. But when I say load register D 1000 without hashtag, what this means? What this means? It means I want to copy a word, because this instruction only work for words, okay, on words. So here I'm gonna copy a word from location 1000, put it in register G, right? As I said before, when I say I'm gonna copy a word from location 1000, it means 1000 and 1001. But I don't need to write the two addresses. Just give me the first address. If it is a word, if it is a byte, I'm gonna read only this address. Like here, look here, guys. Very important to understand this. Look here, guys. Here I put 1000. Here I put 1000. Okay. Here I'm gonna copy a byte. That's what this instruction is doing. I'm gonna copy a byte from 1000. Here I'm gonna copy a word from 1000. So what this instruction actually is gonna do, this one is gonna read 1000, and next one 1001 automatically. I don't need to write the two addresses. Just give me one, and automatically he's gonna get the second one. Is that okay? I think I have, yeah, I'm explaining it here. So here I'm gonna copy a byte, put it in A. So copy a byte. It's a byte that at location 1000 is stored in A. But here, okay, because this instruction for words, okay, here I'm gonna copy a word from 1000, which actually are gonna get 1000 and 1001. Okay, any question? Two things can confuse you. If you listen to me, you're not going to be confused. Okay, number one, if there is with hashtag and without hashtag, right? This can confuse you, but you should understand it. I explained it very well. Okay, with hashtag, this is not a memory, it's a constant value. Without hashtag, okay, so this is actually memory. I have to read from memory. This is one thing can confuse you. Second thing, it can confuse you. Sometimes I read a byte, like this case. Sometimes I read a word. I read a word like this case. Okay. So how I can know from the instruction itself? And every time I teach an instruction, I'm gonna tell you this instruction should read byte or is gonna work on bytes or words. Okay. Okay. I think, yeah, again, I'm making it very easy here. Load A 1000. So I'm gonna read whatever is stored in memory location 1000. I'm gonna put it in register A. Okay, I'm gonna read only 1 byte. Okay, here, because I'm gonna read the word, I'm gonna read 2 location, 1000 and 1001. Okay, and then I'm gonna put these 2 location in register D. But how you do it? Because I have 2 location, I have 2 bytes. Okay, so the way it is done, the first one here, this is the most significant byte. Always we are gonna do that. Yes, always. So that's why FF is gonna come here, 3A is gonna come here. So the most significant byte is stored first, right? So always we will do that. Okay. Now it's the same instruction, it's the same thing, but instead of using load, I'm gonna use store. Okay, as I said, store, you copy register to memory, right? So for example, if I say store register A to 2000, okay, so here I want to copy register A and store it in memory location number 2000, byte as you see here. So I'm gonna store byte to here, right? Now if I say store X, okay, to 2000, okay, so here actually you are gonna copy X, which is a word, to a to 2 memory location, 2000 and 2001. Okay, so this is for a word. Okay, how they are stored? As I said before, the most significant one is stored first at 2000. The least significant byte is stored second, as I said here. Okay, guys, very easy. Again, if it is a word, I don't need to write the 2 addresses. Just give me one, the first address, and then automatically he's gonna take the next one. Any question, guys? Okay. Now you call it direct and extended mode. Why it has 2 names, direct and extended? It's not a big deal. Okay, so actually the RCC, everything is the same. So I don't want you to worry about direct or extended, but also I'm going to teach it, but don't worry about it. So in direct, actually it is direct if your address is from 00 to FF. If your, because here your address can be represented in a byte, right? Because here that's what we call direct mode. In extended mode, it's exactly everything is the same, but here your address needs more than a byte. So if your address is here, you are extended mode. If it is here, direct mode, no difference. It's not gonna make any difference. But just I want to justify why we call it direct and extended. Okay. Any questions before I move forward? Okay. So let me go back again. So just I want you to understand what I did so far, guys. What I did. Let me go back here. Oops. Yeah, here. So I'm done with this part. Now I'm gonna start this part. Remember, anything I'm gonna explain here, guys, we use a pointer. We use a pointer, which means unlike this one, here I give you the address right away, explicit address. The address is here, but here is the address should be in a pointer. You got what I'm saying? So address is stored, for example, in one register, and actually we use 2 register as pointers, X and Y. Okay, that's why they made X 16-bit register, and also they made Y 16-bit register, because I'm going to use them as pointers. This is one thing you have to keep in mind. Second thing you have to keep in mind before I teach this part, usually this part are going to be used if you want to access arrays. We need pointer to access arrays, to read the elements of arrays. Okay, you will see right now. So let me go. Any question before I move to this part? Okay, you look okay. So now I'm gonna move to the next part here. Okay, so now in case of pointer or indexed, I'm gonna take case one. I told you we have 3 cases. Okay, let's see case one. In case one, you put here a constant, right, which can be positive or negative, by the way, comma x or y. Is that okay? So this is how. So once you see this format, once you see something like that, so this is one operand. It's not two; they are together. Okay, so this is one operand, and actually it's one operand. It's a memory location. Okay. And number 3, what is the address? If it is memory location, you have to tell me what is the address. The address actually is the content of x or the content of y, whatever you are using here, plus the constant. This is which address in memory. Okay, so let me give you details. For example, guys, here, if I do something like that, load a 0, x. Okay, so here once I see something like that, this is one operand, this is the format of one operand. Here I'm gonna read the byte from a memory, right? I'm gonna put it in a. Okay, memory, yes, which location in memory should be x plus 0. This is the address. So what I'm gonna do, what should happen is I'm gonna add the content of x plus 0 in order to get the address. For sure it is just 0 in this case, but you can put any number here. Okay, so here, in order to get the address, I have to add the content of x plus the number here, and then give you the address. And then once I get the address, I'm gonna read byte from there, put it in register A. Very important. This instruction is not gonna change x. Very important. Is that okay? Because other instruction should change x. So this one, I just take whatever in x, I add it to this number, but I'm not gonna update x. So this instruction does not change x. Okay, I'm gonna make a quiz. I just want to make sure you understand what I'm teaching. So what I'm gonna do, I'm gonna give you this instruction. I'm gonna tell you the value of x before executing this instruction is this value. So after I execute this instruction, what is the value of x? You got what I'm saying? I'm testing you. Do you understand what I said? Do you understand that this instruction does not change x, right? I just take whatever in x, I add this number, and then this, I'm gonna use this one as address. I'm gonna read a byte from there, I put it in A, but I'm not gonna update x. Yes, is there a question there?
Yeah, so is the register X, or is this a location denoted by X?
This is register X. You got what I'm saying? So what happens, actually, you will see right now, X is a pointer. In this pointer, I have to store address. You got what I'm saying?
Isn't X a
register?
word?
Hmm?
Isn't X a word?
Yes, X is a word. Y also is a word. Yes. Okay. I'm gonna give you examples. Okay. How can you use something like that? I'm gonna give you examples right now. Again, we are gonna use it to read or write arrays. Okay, you will see in some examples now, but let me continue. For example, here, guys, let's see something like that. When I say load register G 1, x, again, when you see something like that, number 1, this is not 2 operands, it's only 1 operand. This is number 1. Number 2, this is a memory location. This is a memory location. Okay, so here that means I want to read a word from memory, I want to store it in register G, right? So, but which location in the memory? How I can get the location? Yeah, because this is a pointer. What I'm gonna do, I'm gonna get what is stored in X here. I'm gonna add 1, okay, and this should give me the address. And then I'm gonna read these 2 locations, this one and next one, because I'm reading a word. This one, you only give me 1 address. Again, for a word, you give me 1 address. Automatically, I'm gonna get the next one. So I'm gonna get the next one, and then I'm gonna store the result in G. I'm not gonna update X. So X is gonna be the same. It's not gonna change. Okay, guys? Any question?
So X just holds the memory location of where you're gonna take the value from?
Yes.
Okay.
I'm gonna give you now details, but actually, if you have array, as I'm gonna explain right now, X should have the beginning of the array. Okay, let me go. I'm gonna explain it right now. Just give me 1 second. I'm gonna explain it. It's gonna be clear. Okay. Yeah, that's what I explained. That's okay. Yeah, it's coming later. I don't know. Okay, let me jump. Let me jump. Just yeah, because you need to understand it. Okay, so um, let's see this example, guys. When I say org 1000 and then buffer is a name of the array. It's not an instruction, just a name. You can put any name here. It's a buffer, just a name of the array. dc.b 3725. What I explained to you before, this is array of bytes. So we're gonna store starting from 1000. We're gonna store 3725. This is array. Okay. So if I wanna read this array, a very one way to do it, one way I can say load register A 1000, right? So by this way, I can read the first element, and then I can say load register A 1001 so that I can read second element, and then I can say load A 1002, I can read element number 3, and then element number 4. I can do it this way, okay? Or look here, I can do something like that. I can say load X. Look here. This is your question. What should be in X? Look here. Load X, and then I'm gonna put here hashtag 1000. So now I'm gonna store in X 1000, which is the beginning address. By this way, 0, comma X is gonna give me first element. 1, comma X is gonna be 1000 plus 1, which will give me the second element, right? 2, comma X is gonna give me second element. 3, comma X is gonna give me the third element, and so on. Is that okay? So usually, if you want to use this way, usually I'm gonna store in X the beginning address of the array, the beginning address, right? And then I can use 0, comma X, 1, comma X, 2, comma X, 3, comma X, and so on to get different elements. So I'm gonna start from here, and then I'm gonna use the constant to shift it, right? Is that clear?
Yes, yeah, that makes sense.
Okay. Another important issue before I leave this slide, guys, is here it was easy to find the beginning of the array because the array comes right after org. So I'm gonna start from 1000. So my array should start from 1000. Okay. However, it's not always easy because sometimes you have some instructions, some variable here, right? So should I count? I'm gonna start from 1000. This variable is gonna take 2 bytes. This array is gonna take 7, 2, and then to get the beginning of the address. No, you don't need to do that. A assembler can help you in that. A assembler can help you. How? Look here, guys. Look, I can say, if I say load X hashtag 1000, it is the same. If I say load X hashtag buffer, just use the name of the array. What the assembler is gonna do, the assembler is gonna replace the name of the array with the beginning address. So you don't need to bother yourself to find the beginning address of the array. Just write the name here, and that's what I explained last time. Every time you write the name, assembler is gonna replace it with the beginning address. So let me tell you the conclusion. Look here, guys. Usually, when I use X as pointer, usually X should hold the beginning address of the array. Is that okay? Usually we'll do that, okay? In order to do that, usually we'll do something like that. Load X, hashtag, and then the name of the array. Is that clear, guys? Any question? Okay. So let me go back. Yeah, I think. Okay, guys. So the second case, I told you the second case in memory. It's a second case if you wanna, in case of indexed memory, you can do something like that: A or B or G, comma X or Y, right? So if I do something like that, B, comma X, right? Again, every time you see this format, you see something like that. Number one, this is not 2 operands, it's just 1 operand. Number 2, this is a memory location. This is a memory location. And because this one is for a byte, so here I'm gonna read a byte. I'm gonna read a byte from this memory location, store it in register A. But which memory location? Which memory location? The memory location actually is going to be the content of register X plus the content of register B in order to get the beginning address here. Is that okay? Okay. So again, this instruction is not going to change X or B, right? Just I'm gonna add whatever here in order to get the address, and then read the byte from here. Okay. So for sure, I am quite sure you are asking yourself, okay, but why we do this way? Why you complicate this way? Why you get one register, add to another register, and then in order to get the address, and then once you get the address, why you complicate this way? I'm gonna tell you why. So don't worry now. How we can use it, I'm gonna tell you how we are gonna use it. Don't worry about that. But just I want you now to understand. If you see something like that, do you understand what this means or not? This is the most important thing for now. I'm gonna give you examples later. Okay. Yeah, I think this is the example I explained before. I told you, yeah. So usually 0 comma x, 1 comma x, 2 comma x are going to be used if you have array and you are going to read different location where x should hold the beginning address, right? That's what I mentioned. I'm going to give you more details. For now, here I can do the same thing, you guys, using b comma x. If you want to read array, again, remember all these indexed are used for arrays. Okay, so if I want to read array, how I can read array? Look here, guys. Number one, x has to point at the first address, first location in the array. This is number one. Number two, so number two, I'm gonna use b to shift x. For example, look here. If I put b is equal to 0, so 0 comma x, so actually it's gonna give you the first element, right? Now if I put in b1, so b comma x is going to be like x plus 1, right? X is the beginning address plus 1. So this is going to give you the second element. Makes sense? Now, if I put here 10, b is equal to 10. So it's going to be 10 plus address, beginning address. So beginning address plus 10 in order to go to this element. Is that okay, guys? Any question? Okay. Another thing you should understand, guys, look here. Let me go to previous, I'm sorry. Look here. Here, I assume this is array of bytes. This is array of bytes. That's why every time I add 1, so 0 comma x, 1 comma x, 2 comma x, and so on, every time I add 1. However, if this is array of words, right? So it has to be, I have to add 2, right? Because this element is going to take 2 location, right? So it has to be 0 comma 1, 0 comma 1, and next one, 1 comma, so 0 and 1 are together, one element. So this is, so I have to use this one for element 0, and then you have 2 comma x for element 1, right? So every time you have to add 2. Same thing here, same thing here. If you here 0, and every time you have to add 2, right? So in element number 1, you have to add 2 because every element takes 2 locations. Is that okay, guys? Any question? Okay. Okay. So here I'm explaining. So now I explain 2 ways, as I said, in order to use a pointer in assembly, constant comma x, as I mentioned, or it can be one a or b or register d comma x or y, right? Here also you can use x or y, by the way. And I told you the idea here, but let me see. Yeah. Here, as I said, the idea is you can x, you have to initialize x with the beginning address of the array, right? That's what I said. In order to initialize x, very easy. All what you have to do, you have to say load x hashtag, and then you have to put the name of the array. Always we are gonna do that. Always we will do that, right? Once you do that, you actually, because as I mentioned before, as the name of the array is going to be replaced by the beginning address. So this one will be actually similar to this one. Listen to me, very important. I know students, once you see this one, you are confused, hard for you. Once you see this one, yeah, that's easy. This is just a hashtag and number. So I'm going to take this number, I put it in X, right? But this is difficult for you. But they are the same. They are the same because the assembler is going to replace the name of the array and then it's going to write the beginning address. So they are the same. Don't be confused, right? Another important issue, again, it's not difficult. I hope you are not confused. Look here, guys. If I say load G and then buffer, and if I say load G hashtag buffer, right? This buffer is confusing me. That's too bad. Very easy. All what's gonna happen, just assembler is gonna replace buffer with the beginning address. Yeah, now it is easy. If I say load D 1000, it's easy. Why? Because I'm gonna read 2 bytes in the memory, 1000 and 1001. I store it in G, right? But here, because it is a hashtag, so I'm gonna store 1000 in G. You understand what I'm saying, guys? So let me say it again. If I say buffer, so actually here, this one is gonna be replaced by an address. So here I'm gonna read, this is a memory location. I'm gonna read 2 bytes in the memory, store them in G. But if you put here hashtag, so actually you are gonna store the number, the beginning address here, right? Any question? Please don't be confused. Please try to understand this slide very well, okay? Okay. Now let's go back. Here I told you I have array and I want to read array. So in order to read array in my program, I'm gonna say load A1000, load A1001, and I can go this way. Or I can say load X buffer, whatever the value of buffer. I don't need to bother myself to know where this one starts. I'm not gonna bother myself. I'm gonna say load X buffer. So the beginning address will be in X. And then I can say read 0, x, 1, x, 2, x, 3, x. I can do this way as well. Okay. However, what if your array is too big? What if I want to read 100 location in the array? Okay. Or 200 location. Should I write 200 instructions this way? So answer for sure, no, we don't do that in programming, right? So this idea may be okay if you want to read a small array, but if your array is too long or too big, in this case, what usually we do in programming, we use loops, right? That's why they invented loops in programming. Instead of keep writing the instruction, this instruction 100 times, no, I'm gonna write it only one time and then I'm gonna loop. So how can we do that? Using how I can loop? Okay, that's what I'm gonna explain right now. Okay, so look here. This is I'm explaining how we can read a big array. Look how it is, guys. Number one, as I said, you have to use this one. I'm gonna say load X buffer. So here I actually initialize X, my pointer. X is my pointer. I'm initializing X with the beginning address of the array, my pointer. Is that okay, guys? And then look here. I'm gonna do what I'm gonna do here. 0, x, put it in A. So I'm gonna write element. I'm gonna read element number 0, the first element, right? I'm gonna read one element, and then maybe I'm gonna do some operation here, some instructions here, and then here I'm gonna increment X to move to the next element. Is that okay? And then I'm gonna loop back, and then I'm gonna read one element, okay, pointed by X. Then I'm gonna increment X. Is that clear, guys? Let me get the pen. Just okay. This is usually what we are gonna do. Let me see if okay. Let me see if I did it here. Okay, no, it's not explained here. So I'm gonna write it here. Look here, guys. Oops. Okay, bin. Okay, look here, guys. That's what I'm saying. So this is the array. X is here. In the first iteration, X is here because here I'm gonna put the beginning address in X, right? After one iteration, I'm gonna increment X. So X. So here element number 0, element number 1, right? Then in next iteration, I'm gonna increment x. So now I'm gonna work on element number 2 and so on. Very interesting. So what I'm doing here, guys, is every iteration, I'm gonna read one element from the array. I'm gonna work on this element, and then I have to increment the pointer so that next time x is gonna have the address of the next element, so that when I come back to here, I'm gonna read a new element. Is that clear? Any question? So every iteration here, I'm gonna read the element pointed by x. Okay, I'm gonna take one element, I'm gonna do some work on this element, and then I'm gonna increment x so that next time I'm gonna work on in next element. Is that okay? Any question? Pointer. Okay, I can do the same thing as I did here right now, but using the other format, a comma. That's what I'm explaining here. So this program is exactly similar to this program. The only difference, here I used the format constant comma x, right? Again, you can use x or y, okay? Because when I most of the time I use x, student may think it has to be x. No, it can be x or y, okay? Here I'm gonna do the same thing but using this format b comma x. So look how I will do it. Number one, x is gonna point at the beginning address. I have to initialize x. Number two, clear b. So b now is equal to 0, right? Number three, I'm not gonna change x as I did before. Here, I'm sorry, let me go back. Here what I did, in every iteration I increment x, right? Here again, this is just a second idea. Okay. So here I'm not gonna increment x every iteration. X is gonna be fixed. So what's gonna happen? Look here, guys. X is gonna be fixed here to the beginning address. Okay. But remember, when I use this format, my address is x plus b, right? So I'm not gonna change x, but I'm gonna change b. So if b is 0, I'm here. If b is 1, I'm here at element 1. Right? Because it's going to be x plus 1. I'm going to shift it by 1, right? If x is 2, so it's going to be here at element number 2 and so on. So that's what we're going to do right now. So let's see, guys, how I can read the array. Number one, x is pointing at the first location in the array. B is 0, okay? So I'm going to read the location 0 plus x, b plus x, which is 0 plus x, tamam? Okay? Which is the location pointed by x. This should be the first element. And then I'm gonna increment b, and then I'm gonna loop back to here. So now it is 1 plus x. Next iteration number 3, 2 plus x, 3 plus x, 4 plus x, and so on. That's how we read different elements. Any question here, guys? Is that clear? Okay. So let's move to the. Let me go back. Just I don't want to get lost, guys. So let me go to the big picture I explained here. This is a big picture. Sorry. Looks the arrows are, yeah. Okay. Oops. Yeah. Look here, guys. I said we have 4 different formats for memory. Okay. I already explained this one. I explained this one. Okay. 0 comma x, 1 comma x, and I told you these 3 are used pointer. Usually they used for arrays. Usually, okay. I already explained this one: a or b or d comma x or y. That's how you can. And I explained how we do it. All what I'm gonna do, x is gonna point at the first element in the array. The x should hold the beginning address or the first address in the array, and then you can say 0, 1, 2, 3 in order to read different elements. Or you can increment x, as I mentioned. You can say 0 comma x, and every iteration you increment x, right? Here a or b comma x, as I have just explained it. X is pointing at the first location. B is 0. Every iteration I increment b, okay, so that I can read different elements. Now I'm gonna move to the last part here: auto increment and auto decrement. Is that okay? But before I explain this one again, I want to say something very quickly because I don't want to be confused. Look here, guys. Here I am reading array of bytes. I am reading array of bytes. That's why every time I increment by 1. Make sense? If it is array of words, so every time I have to increment by 2. right? So x has to be incremented by 2, right? Same thing here. Here, b, I increment b by 1 every time. If it is array of 4 this, I have to increment b by 2. Okay, guys? Great. Now, let's move to the next one here. So here, I told you the way you are gonna so here, this one is called indexed with prefix or post increment, pre or post increment. Okay, but before I teach you this one, let me teach you something in C language. You should be familiar with it because it's very close to this one. So let's see in C language. Do you remember, guys, in C language, when you did something like that, y is equal to x plus plus? You remember something like that? They told you in C language, this instruction actually is just a 2 instruction, but it's just a very compact way. And instead of writing 2 instruction, I'm gonna write it in just in 1 instruction, right? So this one is exactly equivalent to these two. I'm gonna assign x to y, and then I'm gonna increment x. Is that okay? That's what we call post. Why it is post? Because you assign first and then you increment, right? This one is called pre. If you look at the difference, so let me make laser here. Okay, so look at the difference. Just it's exactly same thing, but plus plus. I'm gonna put it in the beginning, pre, as you see here, right? So here, this one and this one are gonna do the same thing, two operation. But look at the order. Here I'm gonna assign first and then increment. This one I'm gonna increment first and then I'm gonna assign. That's why this one is called pre-increment. You know, in English, pre means before, right? So you have to do increment first and then you assignment after that. Okay, this is for increment. You can do the same thing for decrement. Okay, this is C language. We're gonna do exactly the same thing here in assembly. All right, so so if I do something like that, look here, guys. Oh, here, look here, load accumulator a 0 comma x and then increment x, right? So here I'm gonna read the byte pointed by x as I have just explained right now, and then I'm gonna increment x. Is that okay? So this one is the same if I make it compact this way. Okay, so if I say load accumulator a 1 comma x plus, that means it is these two instructions. So I have to, I'm gonna read the byte pointed by x and then I'm gonna increment x. If I put the plus here, it's gonna be is increment first. So I'm gonna increment first and then I'm gonna use this one. So very simple. How I'm gonna use this one? I'm gonna tell you how. Very simple. Look here, guys. As you see here, in every iteration, I'm gonna read the element pointed by x and then I have to increment x. You agree with that, right? Okay. So all what you can use these two instructions all the time. That's okay. However, you can do it compact. So instead of writing 2 instruction, I can do it in 1 instruction. Okay. Again, so if you put here 1, I'm gonna increment by 1. If you put 2, so I'm gonna increment by 2. I'm gonna add 2, right? So let me give you more example. So this actually all the different formats I can have. Look here, guys. I can say a number 1 or 2, whatever, 1 comma x plus. Okay, so this one actually it is post. So this instruction is actually equivalent to 2 instruction as we see here. I'm gonna read a byte pointed by x and then I'm gonna increment x as you see here. Okay, but if I move this plus to here, it will be something like that. So plus here. Okay, so I'm gonna increment first, right, by 1. So I'm gonna add 1 to x, right? Again, if it is a word, if it is array of words, you have to put here 2 instead of 1. But anyway, and then you read, right? If this is if you add. If you subtract, you can put minus here. Honestly, most of the time we can use this one. If you ask me how we can use this different format, I'm gonna tell you how. Look here, guys. If you want to use this format, so x has to point at the first location of the array, as you see here, right? And then every time you use this one, you actually I'm gonna read one element and then increment x. So I'm gonna move this way. In every iteration, you read 1 and you increment x. Okay. However, here every time you decrement. Again, I don't think you need it. You need this one, but just you need to learn it, right? Just in case. But most of the time, if you have array, I'm gonna start from the beginning and then I'm gonna go this way, right? But here in this case, if you have to use this one, what I have to do here, x has to be at the end, so x has to point at the very end, right, of the array, and then I'm gonna go up instead. Again, I don't think this one, maybe, I mean, for array usually it doesn't matter if you wanna go. Most of the time it depends for sure on the programming problem, but usually it doesn't matter if you want to go from the beginning to the end or the end of to the beginning, maybe. So here I'm gonna go to from the beginning to the end, right? Here, because this one can be exactly like this one, but the only difference is if you want to use this one, guys, so x has to be one byte before, one before. It shouldn't be exactly the same. It has to be one before. Why? Because this one is going to increment first. So in the first iteration, I'm going to increment and read, increment and read. So if you have to use this one, put it one before. Again, I don't want to overcomplicate things, guys. Pretty simple. Most of the time, if you have array, normal array, you can just use this one all the time and that's it. But you still need to learn this. Who knows? You may need them. Okay. I have more example here. Okay, very important. If you have, because that's what I'm gonna ask in the quiz as well. Okay, so here, if you have this format plus here, this instruction is gonna change x, right? So let me clarify here. But look here, guys. If I say load a 1 comma x, so what this instruction is gonna do, I'm gonna read the location pointed by x plus 1, a byte from there, and then I'm gonna store it in register A. Okay. However, and this one does not change x. I'm gonna ask about this in the quiz, believe me. Okay. I just want to make sure you understand how this one works. Okay. But this one actually is gonna change x, because this one you are gonna read the byte at the location x plus 0, put it in A, and then this one is gonna increment x. So in the coming quiz, also on Thursday. Okay, we're gonna have a second quiz on. I can put them together in one quiz on Thursday. Uh, I'm gonna give you an instruction like this one. I just want to make sure you understand. You understand this one. Okay, so I'm gonna ask, what after you execute this instruction, what is the value of x? After you execute the instruction, what is the value of x? I want to make sure you understand this one doesn't change x, but this one it changes x. Okay. As I said, if it is array of words, every time you have to increment by 2, right? Because when I say, for example, load, maybe I made, it was not a good idea to use here because this may confuse you. So let me write something here, pen. Okay, so make it because y, sorry, G, register G, okay? And also here, register G, okay? So here what I'm gonna do, I'm gonna read the word, okay, from memory, put it in register G, okay? So what I'm gonna do here, guys, I'm gonna read the word from 0 comma x location, right? And next one automatically, and then I'm gonna increment x by 2, because this is array of words. Every time you read element, you have to increment by 2, right? Any question? Okay. As I told you guys, any instruction should have should have source and destination, right? The source can come from a memory location, and for memory, I explained how many ways for memory, 4 different formats for memory, right? For register, as I said, you can just use the name of the register. Immediate value, use a constant value. For destination here means the result, where you want to store the result. For sure, I can store the result in memory, or you can store it in register. For sure, it depends on the instruction, but these are the options we have. Okay, guys, any question? So okay, save. Let me go to, sorry, where is, yeah, oops, this is another one. Okay, so let me, um, okay. So before I finish this part, guys, this is a summary, because on Thursday we're gonna have, as I mentioned before, we're gonna have 2 quizzes. Okay, in one quiz. Okay, sorry. Yeah, as I told you, number one, in one quiz, I'm gonna give you, yeah, I'm gonna give you something like that. Yeah, I'm gonna give you something like that, and then I'm gonna tell you, tell me how it is stored in memory. Okay. Also, I'm gonna tell you every time I use J, or every time I use I or J or array one or K or array two. Okay, this will be replaced by what address is here. You understand what I'm saying? That's what I'm explaining right now. If I want to read this array, right? So I need to know the beginning address. You don't need to bother yourself to count. This 1,000, this is gonna take 1 byte. This is take it two. You don't need to bother yourself to count. Just you can use the English name, the name of the array, and then the assembler is gonna replace it with whatever the beginning address is. Is that okay? So this is the first quiz. Second quiz is gonna be about what I explained today. By the way, the name of the topic today is called addressing modes. Let me write it here. Addressing modes. So these are the different ways you can represent registers, immediate value, memory location. Okay. So what will be in the second quiz? Okay, what will be in the second quiz? I'm gonna give you something like that. Okay, and then I'm gonna ask you what is the value after we execute this instruction. What is the value of register A? I just want to make sure you understand. Hashtag 20 means it's number 20. Is that okay? Uh, Also, something like that. Just I wanna make sure you understand. This one means it's immediate value. This one immediate value has to go to X, right? Um, Same thing here for memory. I just want to make sure you understand this is a memory, right? So you're gonna read byte from memory, right? Or here this is immediate value, and so on. Okay. And also I want to make sure you understand 0 comma x, what it means. 1 comma x, 1 comma x plus all a comma x, b comma y, all the things. I want to make sure you understand it. Okay. um, yeah, sometimes it's slow. uh, yeah. Okay. So okay guys, so here now I'm gonna start teaching instructions. Okay, but before I start teaching instruction, there are two things I want to explain now, guys. Any instruction I'm gonna teach you guys should have one of these formats. Okay, some instruction has only opcode. Okay, what it means only opcode? That means you don't need to put any operand next to it. Okay, as you will see, right? So for example here, like something like increment x. So this is, you don't need to put something next to it. Okay, and if in this case we call it is inherent addressing mode. So what's the word, what you mean by inherent? It means you don't need to write anything next to it, because the operand is already with the instruction together. As you see here, guys, this instruction is called increment x, right? So I don't need to add anything, because already the opcode here, it has the operation and also it has the operand together. That's what we call inherent. Okay, this is one thing. The other thing is, sometimes some instruction,
You cut it down.
some instructions, it needs opcode and then you have to put one operand here. Some instruction opcode and then you have to put two operands here. You have to separate them by a comma, and then you have also, we have these very few instructions. It has opcode and then you have to put three operands here. Is that okay? You will see now. This is all the format for instruction we have. Okay, some instruction we call them inherent. You don't have any, you don't need to put anything here. Some operands here, you need to put one, right? One or two or three. Okay, just give me 1 second. Maybe I need to tell you something here. So let me, yeah, so let me, Okay. You remember the instruction set table, right? This table. Let me make it bigger. Okay. So you have this PDF file on the Word, on the course website, guys. So now I think I finished everything here. I just want to go through them to so this is what I'm gonna teach, guys. I'm gonna teach what is the format of this instruction. Like for example, EBA. That's what I'm gonna teach. This is explanation to what this instruction is doing. Okay. And now I want to explain this column. Here in this column is gonna tell you what addressing mode you have to use with this instruction. As you see here, guys, this one is inherent. Inherent means you don't need to put anything next to it. Some instruction you will see, it is immediate, direct, extended, indexed, and so on. So all of these things are defined in the file. So here you can learn what for sure when I teach every instruction, I'm gonna tell you what addressing mode you can use with these instructions. Is that okay? Because some instruction you can use memory with them, some instruction you cannot use memory, so you can actually you can know from here what. So for example, this one is inherent, so you don't need to put anything next to it. This is number one. Another thing I forgot to tell you guys is I told you before, after we execute every instruction, the flags are updated automatically, right? This is not very accurate, by the way, because this is different from one instruction to another. Some instruction can change all the flags. Some instruction can change only one flag, two flags, so they are different. So how can you know? How can you know what flags are going to be changed by this instruction? This one is going to tell you. So here, guys, if you see, for sure, if you go to this file, you will see all these symbols are defined, what they mean. But if you see this triangle, this triangle means this instruction is going to change the carry flag, it's going to change the V flag, it's going to change the zero flag, it's going to change the N flag, right? So if you do this instruction and there is there is carry flag, yes, this instruction is going to change this flag. However, if you go to this instruction, can you see this dash? Dash means it does not change this flag. Very important to learn it, okay? Because sometimes you use one instruction and then you think this instruction is going to change the flags, and then after use this instruction you check the flags so that you want to do something. However, it's not going to work if you don't check and you make sure this instruction is going to change the flags. So let me tell you the summary. My summary here, what I want to say, guys, very important. This column here can tell you what flags can be changed by these instructions. Is that okay? So yeah, so this one is going to change all. That's okay. This one is not going to change any flag. What you mean? I mean, if you even if the result is zero, if the result of this operation is zero, right? Zero flag is not going to become one, because this one is going to be the old value, whatever value before you use this instruction, because this instruction does not change the flags. Is that okay, guys? Any questions? You have this table, you have this file for all the instruction. Okay. Let me, well, still we have 2 minutes. Maybe I'm gonna explain also something else. Sorry. Before I forget, we're gonna do lab 1 on Thursday. Okay. Yeah. Oops, what is it? Let me go back. Yeah. So here, I want to tell you something about extending byte to a word. Listen to me, guys. If you have a number in a byte and I want to store the same number in a word, you get what I'm saying? I have a number. This number is stored in a byte. And now I want to store it in a bigger space, in a word, right? So that after I store it in a word, I have to get the same number, because I don't want to change the number. I just want to extend. I want to store it in a bigger space. How can we do that? Okay, I'm gonna tell you how. Number one, If your number is unsigned, in order to extend this number, just put zeros here. Okay. Again, if your number is unsigned, for example, I have this number 11111. Okay, this number is 255. It is stored in a byte. If I want to store the same number, I put it in a bigger space. I want to put it in a word, so just to put zeros here. Okay, even if you put zeros, this number is still 255. I didn't change the number. Is that okay? Now, if your number is signed, okay, if it is positive, if your number is positive, you are gonna do the same thing like this one. You put zeros, you are gonna get the same number. For example, this is number 3. Okay, if I put zeros, I also got 3, but it's stored in a bigger space, right? So if it is positive, just put zeros. If it is unsigned, just put zeros. Now, if it is negative, what can I do? Just put ones, not zeros. Think about it. If you put zeros, you are going to change the number. If you put ones on the left, this is the interesting part. In negative numbers, if you put ones on the left, this is not going to change the number. For example, let me give you example here. This is -1. So if you put ones here, also I'm going to get -1. So I didn't change the number, right? But if you put zeros here, I'm going to get 255. So the number was -1, and now I changed it. I don't want to do that. Conclusion, very easy conclusion. What I'm saying, if you have a byte and you want to extend it to a word, if this byte is unsigned, just put zeros, and then it's guaranteed you are going to get the same number, right? However, if this number is signed, I'm gonna make it easy now. Look here, guys. Just repeat the sign bit. Repeat the sign bit. If the sign bit is 1, just put ones here. If the sign bit is 0, just put 0. Just repeat the sign bits. You are gonna get the same number. Any question, guys? Okay. Yeah, I think it's 421. Any question? Are you okay? Okay. So starting from next lecture, I'm gonna start teaching instructions. Okay. Okay. See you next time. Goodbye, guys. Bye.
See ya.
Bye.
Have a good day.
Yeah, you too, guys. Bye.
Well, he's one of my favorite.